So let's get started. So my name is Mark Buckwell. I work in IBM in the Cloud for Financial Services part of our business. Although that's not, I'm not talking about my day job. In effect, I'm talking about what I do globally within IBM with an architecture method course, Architectural Thinking for Security, which has been developed over the past 6 years, now taught across IBM globally, and into MSc cybersecurity degrees in IBM. And we started out putting together a course because architecture and architectural thinking is a bit of a black art. The business side will come and say, we're going to do design thinking. It's going to solve all our problems. How many people here have heard that design thinking will solve all your problems? A few nods. And that I'll be able to create my system that'll be, highly resilient, have performance, have security, all those non-functional requirements, and design thinking will solve my problem. And it was a bit of a black art in terms of the way that we put together architectures. And so today I'm going to take you through that method and the thinking behind it, so that by the end of the session, hopefully, you'll have an idea of the basic principles behind architectural thinking and including security in that solution. Now, I'm not going to teach you all the detail because that is normally in a 3-day course, but it'll give you a starting point. So when we talk about security design, I'm going to talk about the definition of design and architecture in a moment. But when we think about it, we normally think, right, my first problem is I'm going to have to make sure this system is compliant. I know that I've got my security, my policies, my practices, and all the other standards and paraphernalia that an organization puts together to go and meet the legal and regulatory requirements of the organization. And they think, right, okay, so I build my system, and I get to the end of it, and the compliance guys come along and say, well, it isn't compliant. And all they've done is checked against a checklist to see that you've actually met the list of controls that are part of the solution. What they haven't done, and what they struggle with, is risk. And so we started to go and integrate into our, what I would call the engineering part of it. We're starting just before we start coding, before we start putting a system together. We're added threat modeling. So we're going to look at the threats that are part of the system, and that adds new requirements into the architecture that we're trying to put together. And now as architects, everybody says, well, we're going to solve the whole world. We're going to use zero trust architecture principles. It's going to solve everything. And I heard in a previous session, yes, it's not going to be a product, and it's not identity and access management, it's not monitoring, it's not some network security. Zero trust is really about data. And I heard a conversation earlier, well, I'm not going to talk about data specifically, but even as an architect, I have to think about data. And we normally use these techniques, one or more of them, and we do that in an ad hoc way. And so being an architect is a black art, and it shouldn't be. So today I'm going to talk a little bit about, well, how we can make it not a black art, how we can use a systematic process in terms of architecting. Now, when I started out a good few years ago, and some of you might have started out in the days where we had one system, we logged into a terminal, and security was all thinking about username and password. And today, the complexity of what we do is changing. So, for example, we're now thinking about cloud, but we're not thinking about cloud as a single cloud. We're thinking about multiple clouds in terms of the applications that we're building. And we're thinking about connecting those clouds to our on-premise workloads. The crown jewels of the organization, they still don't want to move off-premise into the cloud. So we end up integrating different parts of an application with different components sitting on different technologies and integrating them together. And this seems to be the way the world is going. And that just now makes the whole solution a lot more complex, because now we have data flowing in all sorts of different places. We have policies that are different depending on technology, depending on the cloud provider. And then we have a split of responsibilities between the cloud provider and potentially somebody running our application, and which is another third party, and our actual organization. So we have now a complex set of requirements that we have to go and put together into our solution. So how do we do that in a systematic way so that we can actually extract those requirements and making sure we cover everything in the solution? So these slides will be available online, so you don't need to go and take pictures of them. They're available for you. So we start with the engineering, the design process. We're starting with, well, where do we start? And I wanted to go and set a context, because what do I mean by architecture and where does it fit in? And what we tend to do is overload the word design and architecture. So let's talk about the process to start with. Today, in many organizations, we start with design thinking because we're talking about the users of the system. We're trying to go and gather the requirements, understanding the functionality of the application that we're trying to build. And from there, we'll go and gather some information about the sorts of system that we want to go and build our application on. And I should say, or workload, because that may not be a traditional application, because I could actually say an identity and access management system is an application as well, or a workload. So we start with design thinking, but what it doesn't do is give us the non-functional requirements. It doesn't give us security, performance, reliability, and so on. And so in a normal world, what we'll do is we will add architectural thinking. And so what is architectural thinking? And Grady Booch wrote an interesting tweet from a few years ago. And what he said, so he's an IBM fellow. And if you ever did object-oriented methods and things like that, he's the sort of the founding father of those methods. So all architecture is design, but not all design is architecture. And what he says is architecture represents a set of significant design decisions that shape the form and function of a system where significant is measured by a cost of change. So when I do my design thinking, I might be thinking about the layout of the screen, I might be thinking about the process flow, but I know that I'm going to use a standard application to go and front it. And when I make a decision that I say a particular technology, or I'm going to use a cloud-native architecture rather than a mainframe, that is an architectural decision, and that has a significant cost of change to the system. And that's where architecture comes in. So I now know what my architecture is. And now I'm going to hand it over to somebody to implement it, to realize that. And that's the engineering piece. And in security, if I was doing engineering, I would probably go and look at Microsoft and their security engineering sites and look at things like Adam Shostak and his threat modeling and things like that. So I would know where to go for engineering. But what I wouldn't know is where do I go for a systematic method for architecting security into a solution. And I call it architecting security into solution, or architectural thinking for security, not security architecture, because I'm not developing a security architecture. Security should not be, is just a part of an architecture. It's not an architecture in itself, which is why I try not to go and use that term. Okay, so now I've got my functionality, I've now got my non-functional requirements, including security, and now I've deployed it, but I've got to operate it. And so some operational thinking needs to go into the design of the system. And that operational thinking needs to think, well, how do I run that solution securely? and I continue to do that. And it shouldn't be the last thing in the system. So I've spoken to many architects who think, well, my role is to architect the application. And there's nobody there to architect the management of that solution, the operations. And as you architect the operations, you will find that the architecture changes, and potentially you will have a different application architecture because you need to manage that system. So operational thinking is just as important and should be done actually back in the architectural thinking, because that will change the system. So we've got these steps as a part of our putting our system together. Guiding that is our enterprise architecture. And I use the two terms solution architecture and enterprise architecture. So enterprise architecture is the things that guide our organization. They may be the bits of technology that we use, the things that are almost the constraints that are put on us when we put a solution together. Whereas solution architecture is developing is solving a business problem, an explicit business application, business processes, and the solution architecture is the bit that seems to be all over the place. If I want to go for enterprise security architecture, I would go and pick up the standard book, Enterprise Security Architecture, that's been around for a very long time, and I'd use that as a starting point, some of that thinking. But for solution architecture, we don't have anything. So who should be doing security solution architecture? We have, I consider three roles, and they do it in different ways. We, of course, have a security architect. But they do two things, security architect. One is they will architect security solutions. So if I want an identity and access management system, it's not simply a single box that I'm going to have to deal with. It's got to be integrated with all sorts of other systems, and I've got to architect it. And that security architect that thinks about that system has to go and think about all the other requirements, the functionality of the system, as well as the performance, availability, and so on. So they are, in effect, application architects with the security hat on. And the other role of a security architect is often as a part of a bigger program, where you may actually have an infrastructure architect, application architect, and so on, performance, and so on. And a part of that team will be the security architect. And he's there to advise and guide and supplement the solution that you're putting together. The second role that this is all about for is every application or infrastructure architect. And I split them into two because generally that's what happens. And they have to have these skills as well, because often they won't have a security architect. And it's as easy if they do that thinking than adding a security architect in the team, because they will then inherently think about the security of the system. And as we move from a world of waterfall projects to agile delivery, we've got a new role, the AppSec champion. The AppSec champion sits with the team that's doing the DevOps, sits with the agile team, and actually is more than just an architect. They start to become an engineer. And the role of an architect is changing into actually the architecture, or at least the detailed part of the architecture, is being described by infrastructure as code. It's not just a diagram on a page. And so the AppSec champion has to go and do the threat modeling, has to go and do, and actually has to start to code and understand perhaps what Terraform does and how that can impact the architecture of the system. So I put those three roles as part of the solution. Now, so ideally, they want something with four characteristics. One, they need something that's repeatable, that when you get to the end of the solution, when you have your solution architecture, that you can trust it because you followed those steps. And when I talk to students the very first day on the course, I say architecture is all about communication. It's about communicating whether it's on the page, and your role as an architect is to communicate even verbally, what the solution is. And so by writing that onto a page and having standard diagrams, having standard ways of representing that solution, we end up with something that can be communicated. So your role is to clearly communicate the solution and the security. Because if we don't communicate it, it gets lost in translation. Now, when we come to regulated workloads, it's not just putting a solution together. We have to have the documentation. We need to have what we call assurance. Now, when I was doing it with Common Criteria a good few years ago, we emphasized the thing about functionality and assurance. And compliance is, yes, assurance supports compliance, but assurance covers all sorts of different things, including the documentation, how you record what you're doing, how clearly you document your architecture, how you test it, how you trace the requirements. And we'll talk about traceability a bit later. And it needs to be able to scale to this level of complexity because we're now dealing with a world of hybrid multi-cloud. So those 4 practices we need to put as part of our method. And so where do we start? And now your brains are going on overload. So this picture is a set of artifacts, and I'm not expecting you to read it. I'll simplify it in a moment. But the point is that architecture is not a 6-inch document. In the world of hybrid cloud and agile, it's a set of artifacts that could be actually just documented in GitHub. A picture, a diagram, a table. And so, which is why I draw this diagram of artifacts. There are things that you develop as you go through, just in time, just what you need. And then you can build that as part of the documentation. But really, at a high level, what is that? It's made up of requirements. The things that your system has to be built around. And yes, there will be all the compliance stuff that you've got, yes, but there'll also be the functionality that you're trying to build into that workload, and all the non-functional requirements that people forget about when they do their MVP, their minimal viable product. Anybody done MVPs in the room? A few people? Yeah. They build this solution, minimal viable product, but it can't scale, it doesn't have performance, and it's not a minimal viable product because they've made it a minimal viable product, but it won't work in production, and you end up re-architecting the whole solution. So the requirements at the beginning are the starting point, and I'm going to talk through some of the things that we need to do, and what requirements are part of. Then we take the architecture. I'm going to take you through the decomposition of architecture from the top level, from system context, to the functionality of the application, to the actual deployment architecture in terms of the cloud. And how do we gather the requirements for that architecture? For example, where does shared responsibility in the cloud fit into architecture? And I get into this thing where people talk about shared responsibilities, but they never actually tell you what it means and how you can use it. And then, of course, operations. The operations means that you will change the architecture, and even as an architect looking after the system, you're still responsible for the processes and operations of the system. You may not be doing it personally yourself, but you need to know how to go and develop those components in the system. And not to forget governance. Architectural decisions, RAID logs. 2 key artifacts that as an architect, if you haven't written one, then you need to make sure you know what they are and how to use them. And finally, assurance. So I'm going to talk through each of those things in this little journey. And you'll hear a lot of this over the next few days. Zero trust. The panacea for every ill in the security industry. Yeah. And the principle, never trust, always verify. But I'll come back to the principle. It's really, when I started out, in fact, I wrote the first architecture course in about 1998. And the principle behind the course was understand your data flows, put the controls in place where that data is in transit and at rest. And in effect, we're still doing that today. We're still thinking about, but actually we're just putting more controls into the system. We're raising that bar over time. And it comes back to this thing about compliance. All that happens when you have non-compliance, we have more compliance because we raise the bar. What we don't do is go back and say, well, what am I trying to protect? I'm trying to protect the data flows, where it's stored and in transit and where in processing. So really, in my own mind, it's back to that being data-centric, because you can reduce your cost, because you can focus on exactly what you're protecting. And I've added some traceability through in terms of zero trust as they go through. You could do the same sort of principle in terms of if your own organization will have a different list. This list 6 is just a list of the principles, but you could do the same. So where do we start with the architecture? We start with the boundary. What are the boundaries of the system? And the first diagram is systems context. And if you search on the internet, systems context diagram, you'll find that. And not often they'll say, oh, well, let's look at the actors interacting with the system. What's important to a security architect is there are transactions that are taking place with those interactions. And in those transactions are data flows. So they are useful to understand the data flows of the system. So the first step is to understand the boundaries. And I was working on a deal a few months ago, and they were completely lost. And until they actually set the boundaries of the system, they didn't even know what scope they were dealing with. And so that's the starting point. And then you understand what you're integrating with as well. So that's the top level. And you'll see the little, down the left-hand side, you'll see the little flow that we're going to follow to decompose the solution. And out of that, you can build your information asset register, and you can then use that based on your classification to understand the sorts of controls that you want to go and put in place in the system. You understand the sensitivity of that data. So now we've got the boundaries of the system, we understand the actors, we know what the interactions are, and we know what the data. But often we're given a set of constraints. Our application is going to be deployed onto a cloud infrastructure. That cloud infrastructure is going to have different landing zones. So they're going to have different points at which they're going to deploy the application. So this is actually a shared responsibility stack, as I call it. It hasn't got the full colors in here, but it's actually used for an application. Some of it was on-premise. The crown jewels are on the Zeb platform because it's a banking application, and that's where most of the data is in the industry. Some of it, they started to move to OpenStack, and so that's for servers. They'd use their own virtualization platform. And then they started to move parts of the application based on risk into the cloud. And in fact, there were different clouds because they'd actually move parts of another application onto another cloud. Some of the application will be used on virtual servers, some of them will be on containers, and so each of those different platforms actually have different shared responsibility matrix. And that actually defines the security policy of and the controls that will apply. And those policies may be different depending on whether you're on-premise or you're in cloud. And the clouds may offer different controls as well. And actually, the depth of those controls may be different. So at what point the cloud provider hands off to the application in the system. So we can use that to define what I've called it is a RACI, but I've not used RACI in those terms. I split it into two. The service provider is the bit that provides a service, the APIs, the CLI, the console. And the administrators that use that. So, and this is another terrible, thing that I come across. These architects that develop applications think cloud is magic. I don't need to think about how much it costs or what I need to go and do until I start developing the cloud. And I can see that some people think the same way, have had the same as well. And so you get there and you actually say, well, you still need to manage the infrastructure. And so actually having this conversation about shared responsibilities and building up these responsibility matrix at the beginning of the project now gives you an idea about who needs to be involved. And I was dealing with a bank that said, I said to them, well, who's going to run it? Who's going to develop the application? We don't know yet. But that changes the architecture, because if I go and ask somebody to go and run the infrastructure, and even within that bank it has 3 different IT departments, and they hadn't decided which one, and depending on the one that they were going to use, totally change the application architecture and changes the security. So having this actually helps us as an architect understand what controls are given from the infrastructure provider we're working with or the application team. So now we've got an idea of, we know the boundaries, we know approximately what platforms are going to run the application on, and we've got an idea about what given controls we have in each of those environments, because we know that some of it's running on cloud, some of it's on-premise, some of it's going to be run by a different department, and so on. So that gives us another step in our journey. We're going to use requirements from elsewhere. And I start with diagrams rather than requirements, because it's a very good thing to go and sit down with somebody and draw a diagram, because it breaks down walls and so on, and you start to go and understand the shape of the system. Now, your organization has a set of legal and regulatory obligations. They will translate those into policies and practices within the organization, and that will guide the functional and non-functional requirements. The functional requirements are things like, if I'm going to a process for identification authentication, the process and the steps needed to do that is functionality. It's not non-functional. But I've got to do that, log into the system within 30 seconds. That's non-functional. So when somebody says security is non-functional, it isn't. It's both. So think very carefully when you build your system. Because even as a security architect, I have to be able to go and draw a process flow and understand how the system works. I have to have the skills of a business analyst to go and actually interview people and understand how the system works. But I also have to have the skills of a normal architect to think about the non-functional requirements in terms of performance. Then we build up our application. We start with the functional components of the system. And we start initially to go and do some threat modeling. And I'm not going to go into the depths of threat modeling today. There are many people probably in the audience who could do better than me at it. But the threat modeling, and there are different techniques, you can start with the application thinking about the threat modeling to your system, because you may need to change the application. And it's at a very high level. And like all architecture, architecture is iterative. You'll start, and you might go all the way down to the detail of it, and then you'll come back up again and repeat it. So if your project plan says, I'm going to do my architecture as a sequence, that's never going to happen. It's always going to be iterative. So you start with building your functionality of your system, the components interact, and you look at the data flows. So remember, we looked at the data flows when we had the system context. We're now looking at the flows through the system. So I should have identified the transaction flows. And what I do is I look at the architecturally significant transaction flows. I don't need to look at all of them. I need to look at the ones that are representative of the transactions that flow through the system. And these diagrams are very simple for the size of the room. But as you know, these diagrams get very complex when you start to go and put together a system. So that's your starting point. And you start on a second journey. I talked about requirements. Now we're talking about threat modeling, which is another journey through the architectural thinking process. So now we've got the functionality of the application. We need to apply that and put that onto an infrastructure. That infrastructure, in this case, very simple cloud infrastructure, will contain probably a transit VPC, some other components, and we'll place them into the right place in the system. And now I'm going to have to go and take those same data flows that I thought about in the application and trace them through that infrastructure. But there will be different threats, because I've now added a context of the infrastructure that we're trying to go and build. I also now know that some of those services, that the data store is now going to be a database, and it's not a database that I'm going to run, it's the one that's in the cloud. So totally a different set of assumptions about the system. I'm probably going to use some zero trust practices. I'm going to think about, well, okay, I know my rules. I'm going to need session level encryption. It's going to have mutual authentication. I'm going to have a process that rotates those certificates and so on. So as a part of that, now I'm focusing on the actual data that's being processed in those flows. Rather than having a compliance checklist, tick, 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 I'm now focusing on the application of the system. So now I've done my context, I've sorted my functionality of the application, and I've deployed it in a diagram, a cloud architecture diagram that will show how it's going to be deployed on the system. So now, I can now think about some of the other things that I need to build on my system. So I know that I've got threats. I know that there are some threats that I can't mitigate, some risk that I can't mitigate. And I also know that there are zero-day threats. And so what I need to do is now think about, well, how am I going to mitigate that? So I build up some detection use cases. I list the things that I want to detect and the data that I want to detect. Now, I may not have that data in my existing application and my existing architecture, so I'm going to have to go back and change that architecture to go and detect the different threats in the system. And I'm probably going to go and use those and build those into my SIEM system. And now I'm going to have to think about, okay, if those things occur, what am I going to do? I'm going to have to respond to those threats. So I'm going to build up an incident response playbook, or you can use any other terminology you like, but I'm probably going to build that into my source system. As an architect, I shouldn't be leaving that to somebody else. I'm still accountable for all of this, and I may call in other SMEs to go and deal with that, but I can now go and build up that threat model, that detection use case, that response runbook, and now I can actually deal with the threats that are coming into my system. So I also need to decompose my shared responsibilities. And having a layered diagram is not going to help you much. And so what I've tended to do is I've created an enterprise architecture, which is actually a list of services for the organization, security services. And so that at least then I can reuse that so that when I come to the next project, I have a standard set of services that I'm going to run. And then for one banker, what I did was I wrote for every one of their security services a RACI. That will give me the responsibilities between the security operations team and their customers. And that security operations team may be built within the organization, or it could be outsourced to somebody else, some MSP. So understanding the responsibilities is the next bit. So I've already understood the shared responsibilities, which probably just has security on there. I now decompose that into a set of security services, and I think of services as technology, process, people. So, for example, privilege access management is a service. There's some solution in there, there's some product in there, but there's a set of processes. It has some SLAs. It has hours of service, and this is one of the things that, as we move to cloud, when we had security operations in the past, I could have them on call. And security is struggling with this transition to cloud, where now, if I lose my security infrastructure, my whole application goes down. So now the SLAs of the security infrastructure have changed from, okay, I can respond in 4 hours, to I have minutes to respond to bring my application back up. So you're going to end up thinking about your security services as having the SLAs are probably greater than the applications they're supporting. Because now your security services brings down, if you lose a security service, if I lose my secrets management or something like that, or I lose my identity provider, it's not just one application that goes down, it's the whole lot. So now, as security architects, we are now have to think about resilience and performance and availability. And one bank I worked with didn't think about, well, when now I'm going to change my privileged access management system to deal with, instead of a few hundred transactions per second to thousands of transactions per second, I did that overnight. Surprise, surprise, the whole thing fell over in a heap. So thinking about those processes, now you need to, that will give you your processes and procedures that you can build for the teams that are going to operate those systems to meet the SLAs that you've just set on those security services. So we still have traceability for compliance, and they go all the way through, so policies to requirements to compliance checks. But really, in the middle, we've got this architectural thinking, and we do these architectural decisions. And the most simple form of an architectural decision is a decision, rationale, implication. And you can look around the internet, there's various forms, there are long forms as well of it. But as an architect, if you haven't got your architectural decisions recorded, you're going to have problems when you maintain a system because nobody understands why you made that decision in terms of the architecture. So that's part of the thinking process. But now we have this traceability all the way through. So we can now start to go and build a traceability matrix, or we should have started at the beginning, which actually shows that we have the requirements, we know where it is in the architecture, we know what tests we've got, and so on, and how we're going to build the system. So this is part of a 3-day course, as I said, but all I've done is step through some basic concepts that said requirements are traceable through the system, and that we build this architecture through decomposition by understanding our boundaries, by understanding the data flows, by looking at the application, and then looking at the infrastructure that we build on it. And we have traceability in multiple ways. One, the requirements through the system, the threats that we build around the system. And if we put this together as a set, as a method, we now actually have a systematic, repeatable method in the way that we approach architecting a solution. So I thought I'd sort of give it a couple of other closing thoughts as to why you should think about architecture. Because really, a solution can be compliant but not secure. Because if you haven't thought about those data flows, if you haven't had a systematic way of thinking about the threats that go through the system, you could end up with a system that's insecure. So it's another tool in your armory to make sure that your system is secure. And there's a risk that all that happens is when you fail your compliance, they raise the compliance bar, which actually didn't solve the problem when you started with, that actually you're still not protecting the data that really should be protecting. And I don't know, does anybody think the compliance bar is going silly? It keeps on being raised? Yeah. So, and if we can go back to thinking about what are we trying to protect, and thinking of a systematic way of protecting that data, then we can perhaps keep the compliance under control. And the second thing is that really what I found is that security only gets put into a system when it fails, when it gets to the end. So trying to, and you hear repeated in many sessions, I'm sure, that security built in at the beginning means that you don't have the waste in terms of reworking your system. And particularly, that's a problem with architecture because I said at the beginning, architectural decisions cost, and they cost the biggest amount. So if you change your architecture to put security in, then you're going to have a lot of waste and have to rework it. And finally, things to do next. I'd suggest that you perhaps go back to your organizations, think, okay, you've got the design thinking people and you've got the engineering people that, understand, going to use the threat modeling and all the rest. But where's the architectural thinking in your organization? Is it being applied? And is it useful to go and make use of that? So thinking about how you apply that into your systems, and thinking about the problem of hybrid multi-cloud. How do I make it have consistent processes, consistent architectural thinking? And understanding the roles that need to be trained to go and make use of this thinking. And the roles will be different depending on whether you're using a traditional waterfall environment or you're using Agile. And some organizations, they've already got the DevSecOps, the DevOps going, but nobody AppSec champions that are embedding the security into your solutions. So you may even need to create new roles. So that's it for this session. As I was going to say, I put Mastodon up there and I put Twitter. For those people that haven't joined Mastodon, it's the sort of the new Twitter for the security community. There's 20,000 people already active on that particular infosec.exchange. So please join, and I'm sure the administrator will thank me for that. So do you have any, as it falls over. Thank you. So any questions from the audience? There was a mic.
I have one question.
Yep.
Yeah. So do you think the solution architect should be security solution architect now? When you're talking about the roles on slide, I think it was on slide 6.
Yeah.
So do you think the solution architects, like we have different solution architect roles,
Yeah.
do you think the solution architect should be now a security solution architect? Should we change it?
Yeah, so I think there are security architects who there should be in the organization, but I'm sort of, yes, you need the SMEs, but don't depend on them because you can't embed all those skills into your organization. So you've somehow got to go and get those skills out into all the architects and also the people outside the architects who understand the importance of architecture. So yes, you need security architects.
Thank you.
Yeah. Any other questions? Oh.
I have another question. So you mentioned through the zero trust, like application by application, like build a zero trust per application. What's your advice for the enterprise zero trust when you bring a tool and they have their own approach to apply zero trust for the whole application, for all your infrastructure?
So as I said, zero trust is not a product, and I still come back to, if you're doing a solution architecture, those products are useful, they're complementary, and hopefully those products that they're putting in, those services that are enterprise-wide are helping you. You know, I think, you know, there are networking solutions, detect and respond and other things, so they should fit into your architecture and complement what you're doing. So they are important, but really you need to get to think about, you know, you need to go and think about the actual solution and the protection of data rather than, you know, and it's coming back to, the first session talked about data, and I think data is the most important thing. Protecting the data and the resilience of the transactions is the most important part of it.
Thank you. I have another clarifying question.
Yep.
So for your second slide, when you talk about the design thinking, architecture thinking session, what's your advice about when you have an engineer that always want to think about, you know, that specific scenario and the whole session go like into rabbit hole?
So I think you're asking if you have an engineer that thinks engineering but doesn't do architecture.
Exactly, but they need to be involved in those decisions.
They need to be involved in those decisions.
Yeah.
And I think one way is to train up, you know, when I started out as an engineer coding stuff, and sometimes that's an opportunity to actually bring them in and develop the career. So I always think of it as it's not just okay, I need to train them. Think about their personal, you know, position, how you can grow them, and architecture is part of that growth for any engineer.
Awesome. Thank you.
Any other questions?
Yeah, I wanted to ask about security data. I mean, I really appreciated the little diagram, but you know, in a hybrid environment, you're getting all sorts of different security logs from different systems, and you can't grab them all, and some of them are, you know, your cloud provider has, you don't even have. How do you figure out how to, you know, grab critical security data and get that over to the SIEM or whatever, you know,
Well,
but you're going to have to leave behind a lot of stuff. How do you?
Yeah, there's always with cloud, there's the exit cost, so there's a cost of taking the data out.
Right,
So,
and also the architecting cost, because you can't turn your security team into experts into mainframe experts, right? So you have to
Yeah.
figure out how to.
so in a way, it's still coming back to, you need things like mainframe SMEs and other things, but it's coming back to the principles, is that threat modeling, identifying what the detection use cases are, and that should prioritize what data you collect. Because
Thank you.
really, yeah, that's
Thank
the
you.
way I
That's
do
really
it.
helpful. Thank you.
Yeah. One up?
So as we're talking about multi-cloud, right? So, but your diagram and most of your process seems not to be focusing on the multi-cloud. So I will ask, what makes a multi-cloud distinct from single cloud or even on-premise, right? In your security architecture.
Well, what's the difference between multi-cloud and, what's, I suppose, I think of two different scenarios. One is how many people use Azure AD in their organization? But you might be sitting on AWS. So therefore, you've immediately got multi-cloud because you're using two different clouds. So you're using services in different clouds. And you'll find the integration between the different clouds, and that will happen. And the other thing that's coming in with regulated workloads is the regulators are thinking about the resilience, operational resilience, and what they're saying is they're really worried about systemic risk. And the fact is, if you have the whole industry sitting on AWS or on Azure, if you lose that cloud infrastructure, you've now lost the whole industry. So, we've got several clients thinking about, well, how do I make my application run on two different clouds? And that's one of the things that we're doing, is to go and think about with IBM Cloud, is how to help clients do that. So you might have half of your application on IBM Cloud and half of it on Azure. That's fine. And therefore, if you lose Azure, you still have a running application. And that's really the other scenario with multi-cloud.
Okay, thank you.
Any other questions? Are we, I think you've got 2 minutes. No? Okay. Oh, one more.
I think you talked a little bit about AppSec Champion.
Yep.
I'm just wondering if you could talk a little bit about what type of skill set that person usually has and where they sit in the organization.
Yeah, so the role of an AppSec champion. I think the AppSec champion has to have a developer skill because a developer mindset. So often you might end up skilling up somebody who's a developer to put give them a security hat. And I've got somebody who's a cybersecurity graduate, but they're learning some of the development side of it. So I think it's not no one right answer to it, but they still have to be, and they have to want to go and get involved in, doing a pull request to go and make a change to Terraform, or being able to go and speak in the same language as the developers, and work in the same way. Because if they're sitting in their ivory tower, their security ivory tower, it'll never work.
Okay. The challenge is, I guess, they also need to know the data and the users and that side of it as well.
Absolutely. So you embed that architectural thinking into them, and they're probably going to quickly roughly draw diagrams and sit down with the developers to go and improve things, and perhaps record those in GitHub pages rather than the documents, so there's a record, and link that against changes in the system. So they have to be able to go and do those sorts of things as well, and be agile in their way of working, rather than creating large Word documents.
Yeah. Thank you.
Yeah. Any more? We can go then. Thank you.